Imagine capturing every single ray of energy the sun produces. Not just the tiny fraction that reaches Earth, but nearly 100% of its power. It would give humanity enough energy to power civilizations for millions of years, run planet-sized computers, and perhaps even spread across the galaxy. This incredible concept is called a Dyson sphere. But despite the name, it's not always a giant solid shell surrounding the sun. Scientists have imagined several different versions, some possible, others almost certainly impossible. So what would happen if humanity actually tried to build one? The original Dyson sphere. The idea became famous in 1960 when physicist Freeman Dyson suggested that an advanced civilization would eventually need far more energy than a single planet could provide. The logical solution? Build enormous structures around a star to collect its energy. Contrary to popular belief, Dyson never proposed a solid shell. He imagined millions, or even billions, of independent satellites orbiting the sun, harvesting sunlight and transmitting energy wherever it was needed. Today, this idea is known as a Dyson swarm. Type 1, Dyson swarm. The Dyson swarm is considered the most realistic design. Instead of one giant structure, countless solar collectors orbit the sun independently. Each satellite gathers energy and beams it to colonies, space stations, or planets using lasers or microwaves. The biggest advantage is scalability. We could start with a few satellites and gradually add millions more over centuries. If one satellite fails, the entire system keeps working. Many scientists believe that if humanity ever builds a Dyson structure, this will almost certainly be the version. Type 2, Dyson bubble. Another concept is the Dyson bubble. Instead of orbiting naturally, these lightweight collectors use gigantic solar sails. The pressure from sunlight pushes outward just enough to balance the sun's gravity. This allows billions of collectors to float around the sun without constantly orbiting it. Although incredibly difficult to engineer, a Dyson bubble would require much less fuel to maintain once deployed. Type 3, Dyson ring. A simpler design is the Dyson ring. Imagine a massive ring of solar collectors circling the sun along a single orbit. It would capture only a small fraction of the sun's energy compared to a full swarm, but it would be much easier to build. Many scientists believe humanity would likely construct rings first before expanding into larger swarms. Type 4, the solid Dyson sphere. Then there's the version most people recognize, a gigantic solid shell completely enclosing the sun. It looks spectacular in science fiction, but in reality, it's probably impossible. The shell would experience enormous gravitational instability. Even the slightest movement would cause the sun to drift toward one side, eventually crashing into the structure. The amount of material required would also exceed what we could realistically gather from the planets in our solar system. For these reasons, physicists generally consider the solid Dyson sphere an engineering fantasy. What would it take to build one? Even a Dyson swarm would require unimaginable resources. Mercury is often considered the best candidate for raw materials because it's close to the sun and rich in metals. Some estimates suggest we'd have to dismantle much of Mercury and transform it into trillions of square kilometers of solar collectors. Construction would likely be carried out by autonomous robots, mining, manufacturing, and assembling components entirely in space. The project could take hundreds or even thousands of years. How much energy would we get? The sun produces about 386 septillion watts of power every second. Earth receives less than 1/billionth of that energy. A complete Dyson swarm could capture nearly all of it. That amount of energy could power massive space colonies, advanced artificial intelligence, interstellar spacecraft, and technologies we can't even imagine today. Human civilization would effectively become a Type 2 civilization on the Kardashev scale, a civilization capable of using the full energy output of its star. Would we still see the sun from Earth? Probably not. As more collectors surrounded the sun, less visible light would reach our planet. The sky could become noticeably dimmer unless parts of the swarm intentionally left gaps. To distant astronomers, our solar system might appear unusual. Instead of a bright yellow star, they'd detect large amounts of infrared heat emitted by the swarm. In fact, some scientists search the galaxy for these unusual infrared signatures, hoping they might reveal advanced alien civilizations that have already built Dyson structures. Building a Dyson sphere remains far beyond our current technology. but it represents one of humanity's most ambitious visions for the future. Whether it's a Dyson ring, a Dyson bubble, or the far more practical Dyson swarm, each design shows just how far civilization could evolve if we continue expanding into space. One day, our descendants may no longer rely on a single planet for survival. Instead, they might harness the power of an entire star. And when that day comes, the sun won't just light our world. It could power an entire civilization across the solar system.